The electricity industry is a foundation of our modern economy. In most industrial countries, electrification was universal by the middle of the 20th century, and the availability of safe, reliable, and affordable electricity has contributed significantly to economic growth. The growth of this transformative industry is a story of institutions, in particular, intellectual property and regulatory institutions, and the interplay of those institutions with new technologies. Electricity is a relatively young infrastructure industry. Much of the industry's early commercial development took place in the 1880s and 1890s, in large cities in the United States, Britain, and Germany. It was also very much a technology industry, with pioneering inventions in the US, for example, from inventors like Thomas Edison, Nikola Tesla, and George Westinghouse. Invention and patent protection are the dominant themes in the early decades of the industry. Edison and his engineers famously worked for thousands of hours while inventing the light bulb. And between 1879 and the time that Edison's first electricity substation opened in Manhattan in September 1882, Edison had received 95 patents in the US for electric lighting, motors, filaments for electric light bulbs, and the other elements of a direct current electric lighting distribution system. Edison also hired the Serbian inventor Nikola Tesla, who would go on to invent important technologies that remain part of the alternating current architecture and operations of the electric power system to this day. Edison and Tesla disagreed about how to proceed with designing electric systems. Edison wanted to retain his self-contained local direct current architecture, while Tesla advocated alternating current technologies that enabled electricity generation at a large distance from cities to be transported over high voltage transmission. Tesla stopped working with Edison, taking his patents with him, and partnered with George Westinghouse to expand the alternating current system that Westinghouse had been developing since the mid-1880s using European technologies. Westinghouse saw that alternating current architecture would enable a system with large economies of scale, and he worked diligently to create such a system. Collaboration with Tesla gave Westinghouse Electric Company the rights to use Tesla's inventions and patent priority over other inventors. The Westinghouse Electric Company won the contract to electrify the World's Columbian Exposition in Chicago in 1893, and then built the first long-distance alternating current transmission system from Niagara Falls to Buffalo, New York in 1895 using Tesla's inventions. This picture of the turbine hall underneath Niagara Falls illustrates how large the economies of scale were in this new industry. These large turbines use the force of the falls to generate a lot of electricity at a low average cost per unit of output. Over the next decade, firms and municipalities invested in building local alternating current distribution systems. In large cities in the US, like New York and Chicago, city councils granted franchises to multiple competing firms. By 1900 in Chicago, there were as many as 12 electric lighting companies. But with economies of scale and high fixed costs, such rivalrous competition was not sustainable. As some firms found their losses too large, consolidation happened as other firms bought the assets of failing firms and took on their customers. Local monopoly electric companies evolved out of this process of consolidation. Another economic driver reinforced the monopoly cost structure, economies of scope. For example, Samuel Insull was the president of Commonwealth Edison in Chicago, and he realized that since their main product was electric lighting, their generation and distribution capacity were idle for large parts of the day. He proposed to the Chicago Transit Authority that they buy electricity from Commonwealth Edison to electrify the streetcars, rather than building their own generators, and he offered them this service at a very attractive price. This move enabled Commonwealth Edison to use the same set of assets to produce and sell two different products, streetcars during the day and electric lighting at night. These economies of scope reduced the per unit costs of selling electricity even further. These new large local monopolies cause concerns about pricing and excessive profits, especially in the trust-busting mindset of the progressive era in the United States. Would city councils provide the oversight and incentives to keep them from charging monopoly prices? Worries that the answer to that question was no led to a push for state-level public utility regulation based on a public interest standard. Large electric utilities accepted regulation because it created entry barriers, so they didn't have to worry about the high cost of debt as they borrowed funds to buy out failing firms, or they didn't have to compete with new entrants. Thus, public utility regulations acceptance makes sense from both a traditional public interest framework and a public choice economics framework.